Welcome. In this quick tutorial, we write a tiny C# program that checks whether if the first element and the last element of an integer array are equal. This is a small common validation you might use when processing sequences or validating circular buffers. We'll walk through a concise, readable implementation and explain the edge cases where the array length is greater or equal to 1. By the end, you'll know the simple pattern and why it's safe and efficient. Let's jump in. This is a simple check, but it teaches important habits. We validate exceptions, which are array length, and write clear conditions. Because we told the array length is at least 1, we can safely access it. If the guarantee weren't present, we'd first check the num's length is greater than 0. Small checks like these avoid runtime exceptions and keep the code robust. Here's the full program. We declare int and then print the result of a single Boolean expression. The expression does two things. It shows the array has at least one element, which is num's length is greater or equal to 1, and compares num0 to num's length minus 1. Using equals on integer is fine, though equals works equally well here. The whole check is concise and runs in constant time, big or 1. If you later read the array from the input, swap the literal with the user input. The check remains the same. The logic is tiny and intentional. We always check length before indexing when there's any doubt. Here, it's redundant because the problem promises length is greater or equal to 1. But it's a good habit. The comparison itself is constant time. This pattern can be generalized to other boundary checks, like comparing start and end timestamps, or first-last words in text processing. Let's run a few test cases. The sample array returns true. A single element array always returns true because a single value is both first and last. If you expect empty arrays in your application, add an explicit check and decide whether to return false or throw an error. That's dependent on the use case. Although simple, this check appears in many real systems. For example, verifying that a streamed frame begins and ends with expected markers, or ensuring a circular log wraps correctly. These tiny validations often catch upstream errors early and are cheap to run. That's it. A short practical C# exercise with immediate utility. The implementation is concise and efficient. Thank you for watching. If you enjoyed this video, please make sure to like, share and subscribe for more C# tutorials. I'll see you in the next one.